Hey guys, Brian Ghigiarelli. I'm a software engineer at Asymmetrik. The talk today is recommendation engines that we kind of built around behavioral analytics. So we'll talk about what that means as opposed to some other different types of recommendations. It's going to be a mix of a little bit of what's going on, what it should be doing, the math behind it, and then we're actually going to show an implementation of this whole thing actually running. So when we talk about different types of recommendations, a lot of these play interchangeably sometimes, but they complement each other really. So we have different content recommendations that could be like document similarity, so these have a lot of the same text or concepts. Activity is what we're going to be looking at, so that's kind of based on collaborative filtering. So that you could think of more in the, if we've all used Amazon, this is the you may also like, based on what you've bought before, what other people have bought or viewed. Other different types of recommendations could be on time, so Twitter's this is most recently trending, or this was most recently sent out, and then any combinations of those. So the combinations are kind of the key to making it all work, but really it's whatever works for your application or whatever type of data you're trying to present. So when we're talking about behavioral analytics, this in a nutshell is what we're talking about with collaborative filtering. So I have two users and two things. So user A looks at items 1 and 2, user B looks at item 1, so therefore we might recommend that user B look at item 2. And that's pretty much it in a nutshell. So enjoy bagels and so how do we actually do this? From the whole 6 yards, this is kind of what we're going to walk through in this the talk today. The first thing that we're going to do is start up on the left-hand corner here is collect all the views or all the actions that our users have within our system. We then send them through some weight function to just generate all those statistics. We can decay things over time so that older events or actions are less favored. We then build up a user's view on a particular item, so we'll get their kind of score on that. Finally, loop it around. With those scores, we can then say, how similar are these users to other people? And based on that is where we can figure out then, all right, maybe we should recommend a user view a particular item or look at something instead. Finally, one of the things we've seen is that people don't necessarily want to look at only their recommendations. Doesn't necessarily interest them. So we've interleaved them with a lot of what they would normally see otherwise on our application or within our site. And then finally, we feed that all back in, and the loop continues. So the first step after we've kind of collected what our folks are doing, whether that's in log files or in a database or wherever it is we use a weighted decay function. So the math looks kind of fun up here, but the gist of it is that things over time are less relevant. So this is, we're going to be favoring things that have happened more recently, and that's the function or the code that you can use in the bottom right there to actually use this with an inverted ease in, ease out, cubic or quart, whatever seems to work for your data. From there, we can take all these logs that we have for our users on their items or their shopping cart things and build up this matrix of their scores for each of these items. So I did want to highlight one of the things here. It's not just a binary 1-0, but if I look at item 3 100 times, then I might have a score of 100 on that. So it will be weighted based on the magnitude of what you're doing with these things. And we can also say that some of the scores may be varied based on what you do. So if I look at something, that might have a different score or a different accumulation than if I comment on something or share it out to one of my friends. So those are all the kind of things that you can keep building into your scores over time to refine that for what works. From there, others like you. I mean, other people do like you, but this is other people who are similar to you. So we find that with this little bit of cosine similarity math over on the right-hand side. So A and B are user vectors. If we go back to that table, so that's your views or your scores on items. And then we cross-multiply those and divide by the overall magnitude to get basically how much those angles project on each other in some n-dimensional space. This is also used in text matching. So, if a particular document has the instance of a word 20 times, another has an instance of a word 19 times, they're pretty similar based on the combinations of all those words and how much they appear in a document. But what we can do with this is then get your similarity to other people. And then from that, we feed that back into all the numbers that we've had. So user A and B, we've turned the numbers. They are 94% similar. Users A and C are 23%. And B and C, since we saw that they have no overlapping items at all, sure enough, are at 0%. So then from there, what we do is we take those numbers, we take the similarity of you to everyone else, and when we actually implement this, we build in some thresholds. So if you are really not similar, or 5% or so, it might not actually incorporate that into the accumulation here. But for this example, it's pretty simple. So we're saying for user A, similarity to B was it 0.94? 94%, and because user B had looked at items 3 and 4 twice, they get an accumulation there, and then we basically just sum down the columns. So what that means is, now we have recommendations for user A on all these different items. And we can look across and say, all right, well, they are probably more likely to be interested in items 3 and 4, but when we look at this, there was enough prior activity of this person on those last couple items, but they've never seen item 2 before. So maybe we'll recommend item 2 to this user. So is this kind of making sense so far? All right, good. The one thing that we see with this is that once we get the numbers and once we get the recommendations, it's kind of important to interpret them in a way. So, you see here the things that have the highest score aren't necessarily the things that we're going to display up there. And we might find this application in other instances, not that I'm So what we're kind of seeing when we actually implement this and when we have real people using it is that variety is the spice of life. So these recommendation numbers, instead of just saying, show me the top 5 things that I might be interested in all the time, that's a very static list, and we're always about showing new content and new dynamic applications. So we actually run those numbers through a cumulative distribution function in order to get a kind of a weighted random sampling of the recommendations. And then that allows us to mix those in, get a little bit of variety in there, and then see how our user base reacts to that. And yeah, beyond there, so we also add some custom filtering in order to say, well, if I'm looking at a particular page, I might not be interested in one kind of item or one type of shopping cart thing that I'm looking at right now. So maybe I'm on a home appliances page, so I'm not necessarily going to recommend pencils or pens. So once we've put it out there, we wanted to see, this is actually running in a reporting application. So once we put it out there, we wanted to see how people reacted to it. And overall, it was pretty exciting. We got good responses from it. The one thing that we did find was that for people who had very little activity in the system, they only wanted to look at one thing that they knew they were interested in. From that, we were able to expand what they would look at by enabling this personalized discovery. So we knew what you had looked at before, we knew what other people had done. So from there, we were able to recommend other things, and that kind of expanded the usage for each of those people that we would recommend to over time. Of course, there were others that said, hey, that's great, but I'm still going to do my one thing and just focus on this one thing. And other people were more kind of saying, well, don't clutter up with all these extra things, and I don't trust tools anyway, so I'm just going to look at what I want. So there's also one of the things we're going to show is that we built in a do not recommend list. So when you're on Amazon, you say, actually, don't show me this thing ever again. So adding those into the filtering. So that said, we did find that when people said, don't recommend this to me, or I'm not interested in it, they would still take activity on that particular item over and over again, whether it was commenting on it or whether it was viewing it. So we were still keeping score over time to be able to feed the engine. Okay, so one of the things that we did a couple months ago is we actually put this in use at Asymmetrik and had folks just log in here. So we presented to our team of analysts and engineers a big list of movies, and we said, all right, everyone got anonymized logins that you'll see in a moment happen to be former presidents of the United States. So we didn't actually get them to do this, but and had them go through this list of movies and say, all right, just pick what you like. We're going to run this engine over all of those data points and then see what we recommend from there. So this kind of walks through each of those different steps of calculating user scores on items, in this case movies, building up the user similarity matrix, and then providing recommendations. So what do you like? You see the ones that are highlighted in green here as what I've picked. If I wanted to add any others, just keep clicking around. And we can see that the list goes on a little bit. Some of the images I pulled from IMDb may not be working anymore, so sorry about that. The next thing is, once we have all these likes, you can see that these are the different actions that were fed into the system. So these actions all happen to be like in this case, but you can see that you would weight different actions more or less over time. And from there, we actually built up, when we ran the engine, built up the user similarities. So I have a similarity to myself of 100%, which is good, right? If I didn't, that'd be weird. Or the math would just be horribly wrong. From there, then, I can see that I have a similarity to Bill Clinton of 43%, or whoever had the user Rocky Balboa, or Amit. And we can kind of look at what these numbers actually mean. So if we look at all the movies that I liked, all the movies that they liked, how much do they overlap? And this was kind of a way of saying, all right, what does it mean to be 43% similar to another person? And go back a moment and see if we can find another one. Let's see what my wife picked. She liked a lot more movies than I did. Oh, that's good. She wanted to test out how robust this engine actually was. And it worked pretty well. So when we ran it over, what do we have, about 30 or 40 people or so, across 60 different movies. I mean, the whole thing ran in about less than half a second or so. But from there, with all the similarities that we span across all the users, when we bring them up, now we can see that my recommendation, this is just an ordered list of everything that we have from the numbers that came out. So Indiana Jones, Shrek, and Inside Out are the top recommendations. But when we actually present these, we would use these as random weights to pick which one we would actually show. Any question on this so far? So that's about it for the demo.
I have a question.
Yeah, please.
So is that the same technology that's used by Netflix and On Demand and all of them?
That's a good question. They used to use things like this. I'm not sure if they still do. What I believe they do is kind of a combination of something like collaborative filtering here, as well as anything that's recently released and sponsored. So it's going to be one of those aggregations of all these different analytics. Okay. But I imagine that they probably still use something like collaborative filtering as an input to what they would provide.
Okay.
Yeah. Sir?
In the do not recommend. Is that, excuse me, is your application like for the movies, could you also do that? Say, do not recommend a given movie. And then the question would be, does that influence the recommendation results for others?
That's a good question.
Or is it just filtered out of yours?
Right, right. So what we've, in the application that we have, what we've seen is that the do not recommend would just filter it out for you. So if you kept looking at something, then, which is what we found, folks really just wanted a way to prune the list of things that they saw so they don't have to sift through so much data. But from what we saw was that they kept taking action on these things, so it was still relevant to them in some way. But with the way that the algorithm works, the cosine similarity, if instead it was implemented as a do not recommend would be a negative score, that would work just as well. So if you're considering the math, when the angles are completely opposite, they project further away from each other. So it would include that in the weights that that user had on everyone else. Yeah.
And a second question. Have you done the example where your audience might have had malicious intent? In other words, where somebody logs on, I guess you only get one chance to recommend or not recommend a movie, but do you consider at all the idea that somebody may take action to increase log entries to favor a result of some kind?
Yes, absolutely. So that is, when looking at collaborative filtering, that's called user bias. So you can tailor the bias in different ways. With what we did for the movies, we didn't use any user bias because it was either a like or a not like. But the application and the code that we're going to bring up in a moment, the little open source utility that we built around this, would take in user bias. And you can configure that in different ways depending on what you want to do. Yeah. As far as performance tuning, when we want to see how will something like this scale out to a lot of users, a lot of, it keeps saying items, but generically anything. So no matter what that could be, how do we scale this out? A couple of things to consider is that a lot of times we'll get a sparse matrix. So we'll have, we saw in this case user B and C didn't have anything that overlapped, so you don't need to process them at all. If they don't have anything in common, you can totally skip all those results. Take advantage of the sparse matrix to basically reduce the number of things we have to crunch on. Additionally, we stored user rows as their own individual sums as an intermediate step instead of having to recalculate that every single time. So if we go back to the similarity, that was the denominator in the equation. So store those off. You only have to run that update once and then apply it to everything else. The application that we built for this uses MongoDB, so we used lean cursors that didn't include all the middleware that Mongo's provided, and we actually just streamed in all the data from Mongo before it was executed over that. Finally, this really allows us to multi-thread everything, so you can calculate each user on their own. You can calculate the similarity between pairs of users on their own, and then finally calculate the recommendation scores all parallel. So it does lend itself to scaling to a lot of users, a lot of data. Beyond that, I mentioned that this was something that we open sourced. So at Asymmetrik, Akin, there's actually a Node.js application that will be, I think, available on NPM soon. But you can include this in anything. There's some decent API documentation out there, but feel free to give us any comments or let us know, what you like, what you don't like about it. Yeah, you can follow us on Twitter or anywhere else. So, see you on Monday. Thank you guys for listening to the talk. I hope it was useful. I hope there, if you guys have any questions afterwards or anything you didn't want to ask, feel free ask me. And appreciate your time.
Thank you.